Okay, can you hear me? Can you hear me? Anyone? Okay, right. Now, some time ago, uh, is Hoshini was doing this differentiation, and she told me that she doesn't know how to differentiate, and she gave me one problem, and the problem is differentiation, but it involves fractions, the whereby the index is a fraction. So when I was teaching you, I told you that fractions, indices with fractions, they are not us, right? But somehow, when they look at some of the trial exam papers from other states, and I don't know from where, they do ask the question with fraction, fractional indices, right? So I'm going through with you how to differentiate when the index is a fraction. When the index is a fraction. Okay, right. So I start off. Well, let me summarize it. So I'm going to show you 4 examples. The first example is our basic integration, whereby the index is an integer. So if the index is an integer, how? We look at it. So first example, index is an integer. Second example, the index is not an integer. Then the next one, we have a product of two functions. A very simple product where you do not need to use the product rule. And I also show you how to differentiate the quotient of two functions. Very simple function where you can divide them or you can split up into two or more terms, and you can differentiate them one by one. And again, all these examples involve indices that are fractions. Okay, first of all, the first one. So to refresh your memory, we are going to do one example whereby the index is, or the indices are integers, not only whole number integers. Integers means you can have a positive index, or the index is a negative number, like in this case, right? So now if you are given a function or an equation like this, 3x to the power of 5 plus 2 over 5x to the power of 3, okay, 5x to the power of 3. And how are you going to differentiate this function? So first of all, you try to express these two terms uh, in this form, right? The x, whereby the x is at the top, the x is not at the bottom. So if the x is at the bottom like this, you have to change them to x to the power of negative 3. And remember the fraction 5 over 2. Now when you move the x to the top and becomes x to the power of negative 3, the 5 still remain at the bottom. Okay, the 5 will remain at the bottom. So the first step is to convert this function into something like this, where the indices, they are all at the top, they are not at the bottom, or the terms involving indices, they are not at the denominator. All the terms are at the numerator. All the terms involving x are at the numerator. So this is something what we get. Now from this step until here, I have not done any integration at all. Okay, so this is merely changing the form from this form to this form, right? Where the x is at the denominator, I change the x to the numerator. So after changing, I'm going to differentiate. Can you still remember how to differentiate? Right. Now to differentiate, you have to separate the number and the term involving x. So at this step, you see that the number 3 is separated. I put them separately. So what I'm going to differentiate is x to the power 5. So inside the bracket is what I'm going to what I've differentiated. So how to differentiate x to the power 5? This number 5 you put at the front, and the index 5 less by 1. Every time when you differentiate, the index reduced by 1. Right? The index reduced by 1. Okay. Now, so this is how you're going to differentiate. So the next term is 2 over 5. 2 over 5 is a number that I'm not going to differentiate. I put it separately. So now I want to differentiate x to the power of negative 3. So the negative 3 I put in front as a coefficient, and the index negative 3 reduced by 1 become negative 4. So over here, right, this step here, I have differentiated all the two terms. So now I need to simplify. So simplify means you multiply the numbers together, right? So multiply the numbers together, 15x to the power 4. Multiply the numbers together is negative 6 over 5. And the x is x to the power negative 4. Now normally you don't leave the x to the power negative 4 at the final answer. Now you leave it in this form when you want to differentiate them. So if you want to leave them as the answer, you have to bring the negative 4 down to the denominator. So the denominator becomes 6 minus 6 over 5x to the power of 4. So far, any question? Am I going too fast? Fast or not? Nurul Iman can follow or not? Huh? Show me your thumb if you can follow, Nurul Iman. Yes, okay, can follow. Huh? So now I'm going to the second example where the index here y equals to ax to the power n, where n is not an integer. Now I did not teach you n not an integer when you were in form 4, because they told me n not an integer is not coming out. So if n is a fraction, they are not coming out in the SPN. But somehow now they tell you that, oh, fractions also is coming out. But during my time or long ago, yes, we at form 5 we also learn, because it's nothing different from what we have been doing. Only thing is that instead of writing an integer there, you write it as a fraction, and you differentiate the fractions according to the rule that we have learned, right? So now let me show you one example. So the question is like this: y equals to 2 square root, there's no number in front here, no little small number in front here, so this is a square root. 2 square root x to the power of 3 minus 3 over, this is cube root of x squared. Now if the function is given in this form, in the square root form or cube root form, you cannot differentiate, right? Cannot differentiate. So I have to use my knowledge of indices. Now form 3 also they learn indices already, right? So you have to change this form to a single term involving x with a fractional index, right? So what is square root of x cubed? Square root of x cubed is x to the power of 3 over 2. 3 over 2. Now this one, cube root of x squared. Cube root of x squared is actually x to the power of 2 over 3. But because this term is at the denominator, when you move it up, then you have to put a negative sign in front. So far, do you know how to change the equation from the square root form to the index form? Can or cannot? Can, right? You know how to change, because form 3 also they have learned. Form 3 also they have learned. You see this boy at the back there, form 3, he learned all this already. Eh? Right. So you have to change it to index form. Right? So did I do it correctly or not? Liu Ying, did I change it to the correct index or the indices? All the indices correct or not? Please check. Okay, correct or not? Correct, huh? So I've changed it to the index form. Now, in the index form, how are you going to differentiate them? So we are going to follow the rule that I told you earlier, right? I told you earlier. Now, this coefficient, you separate them, put them in front, and create a bracket. So that coefficient 2, you don't differentiate, right? The coefficient, just leave it in front. Then the index here, you move to the front and make it the coefficient. So 3 over 2, you bring down, become 3 over 2 as a number, as a coefficient. Then this number 3 over 2, you have to minus 1. Minus 1. Right. Then the next term, negative 3. So negative 3, you leave it outside. Then you create a bracket. Create a bracket. Then this number, negative 203. So you bring down the negative 203 and make it your coefficient. Then the negative 203 at the index there, you have to minus 1. So this is what you have to do, right? After doing, try to simplify, right? Simplify. So the numbers, I multiply them together. 2 times 2 over 3 becomes 3. So x to the power 3 over 2 minus 1, it becomes x to the power of half. 3 over 2 minus 1 is half. Then the next term, negative 3 times negative 2 over 3. The negative 3 and negative 3 cancel, it becomes positive 2. Then next we deal with the index. Negative 2 over 3 minus 1, negative 5 over 3. So is this correct? Wan Li, did I do the subtraction of the indices correctly? Yes or no? Because a long time I didn't do mathematics. So maybe I make careless mistake. So please check Wan Li, correct or not? Correct, please show me your thumb. So we are now at 3x to the power of half, 2x to the power of negative 5 over 3. So this is correct. Okay. So if correct, then you have to write this back in the square root form. So square root form, x to the power of half is actually square root. So it's 3 square root x. The 2, this 2, positive 2, is at the top. Unless there's a number at the denominator, then you put a denominator. So if there's no number, like in the previous case like this, as a number at the bottom, then you put it at the denominator. Here, no number at the denominator. So you just leave the 2 at the top, and this term, negative 5 over 3. So negative means that this term, you have to write it at the bottom. The 3 at the bottom means cube root. The 5 at the top means x to the power of 5. Can follow a lot? Nurul Iman, can follow so far? Do you know how to differentiate terms where the indices are fractions? Can, okay, very good. Nurul can follow, right? Now, the thing they want me to, Koshini want me to show is, not only they want to she want me to show this square root, cube root, or the root. She also want me to show you this one, the product of two functions. So let us look at one example where we have product of two functions, and we are not going to use the product rule. We are not going to use the product rule. Right. So you see that there are two functions here. Number one, square root x, and the second function is inside the bracket. So square root x is one function, the bracket, whatever that is inside it, is another function. So we have a product of two functions. And these two functions, they are not raised to the power. You see the bracket here is not raised to any power. If it's raised to a certain power, then you have to use function of the function or the chain rule to differentiate. So this time it will be more difficult, right? But not more difficult, a bit tedious, so you have to adjust accordingly. But since they say simple one where you can do using expansion, so I'm going to expand this term, multiply with this one. So this function multiply with this function. Now if it is expressed in square root or cube root form, you want to multiply them, it is quite difficult. So I have to write them is in this fractional form, in this fractional form. So square root x I write down as x to the power of half. Then whatever is inside the bracket, I also express them as power of something, power of a number, power of a fraction. So finally, I have x to the power half, bracket 3x minus x to the power of 1/3. So this is, why so many Liu Ying one? Oh, no more, only one Liu Ying back. Okay, right, so I'm going to multiply. Make sure you change them to fraction form. Once you make them to fraction form, it is easy for you to multiply. Why? You look at it like this. X power half, 3x to the power of 1. Now when you multiply two terms involving x, what you need to do is you add up the indices. So the indices, they are, this term is half, this term is 1. If the index is not written, that means it's 1. So half plus 1, 3/2. Then half plus 1/3, 5/6. So actually when I multiply them, I'm actually adding the indices. So is this step correct? Did I add them correctly? Liu Ying? Did I add correctly or not? The indices, please check. Show the thumb if it's correct. Okay, thank you. So it's correct. So now with this, in this form, I'm going to differentiate. So again, differentiate, I put the 3 in front. Don't do anything to 3. Then this 3/2 I put in front. Then I use the 3/2 minus 1. So 3/2 minus 1. This is the process of differentiation. This is the process of differentiation. So now the next term, this one. So the 5/6 I put in front. 5/6 minus 1. Okay, what you're going to get, right? 3/2 minus 1 is half. 5/6 minus 1 is negative 1/6. So you multiply the number together, 9/2. X to the power half is actually square root x. Now here we have 5/6. So the 5 you put at the top, the 6 you put at the bottom, right? 5 at the top, 6 at the bottom. So it is like this. Then x to the power 1/6 is the 6th root of x. 6th root of x, because there's a negative. So this term I have to put it at the bottom. So Nurul, you see any mistake or not? Did I make any mistake? Nurul Iman, yes or no? No, then you just put a thumb. If everything is okay, you put a thumb. If something wrong, then please tell me, right? So sometimes I make some very obvious mistakes. No need Nurul, anyone check, then if it's correct, you just put out a thumb. Okay, thank you Nurul. Right, now I'm going to show you the actual question that Koshini gave me. So the actual question that Koshini gave me was like this. Now she say she want to differentiate this function, and the don't know the tuition teacher or which teacher say they are not supposed to use the quotient rule. Or you want to use the quotient rule also can, no? But if you use the quotient rule, if the problem is like this, then it's very difficult. So we don't use the quotient rule, we just divide. By dividing, I mean you separate them into terms like that, one by one. Okay, I don't know, maybe it's a trial exam question from other state, I don't know. So the first step is to divide them, separate them, right? So 3x squared divided by x, 3x squared divided by x. 4 to the power of half divided 4 square root x, sorry, divided by x. 4 square root x is 1 over 2, then divided by x. Now when you divide like this, you need to subtract the indices. You need to subtract the indices. Now in this case, when you multiply, we add the indices together. But in this case, when you divide, you have to subtract the indices. So 2 minus 1 is what? 1. So I have x to the power 1. X to the power half minus 1, x to the power 1, x to the power negative half. But the subtraction of 1 here is not differentiation. I am just simplifying the terms. So don't think that, oh, I get x to the power negative half. I have already differentiated. No, you have not differentiated yet. Okay, so you get something like that. And if you have not differentiated, you just simplify the function. In front is still the y. It is not dy dx. But if you put dy dx there, whoever it is will mark you wrong, because you have not differentiated, you cannot put dy dx here. What you are doing is just simplification, so it's still y. Don't make the mistake, don't call this dy dx. Okay, right. Then what is the next step? Next step, from here we are going to divide. We are going to differentiate, sorry, not divide. We are going to differentiate, right? So 3x differentiate becomes 3. Negative 4, you just leave it outside, don't differentiate. Negative half, you bring down negative half. Then negative half, you have to minus 1. So negative half minus 1. Okay, then 3, you just put down 3. Then these two numbers, you multiply them together. Negative 4 multiplied by negative half is positive 2. And how to simplify this? This one, the x negative 3 over 2. Negative half, negative 1 is negative 3 over 2. So this already differentiated. Or you can leave it in this form, but most probably they want you to express it in the square root form. So the 2 is at the numerator. Then this thing you bring down to the denominator. Square root is this. 3 at the top is x to the power of 3. Okay, so this is my explanation. And any mistake or not, you just sprain my neck. Any mistake or not, please check. Liu Ying, correct or not? Correct. Liu Ying said correct. Okay, now so you go through, and if you have any question, you ask. Turn on your mic and ask. If no question, then we go on to the physics problem. Okay, any problem, anything you don't understand, how to differentiate fractions, where the index is a fraction, the indices are fractions? No, no, then we go to the physics. Say okay. Any okay sign in your computer or not? You show okay, and I go to the next problem. No okay sign, only like that. Okay, that's right. Nurul Iman, okay or not? Okay. Yang Wan Li, okay or not? Okay, right. So we go on to the physics problem. Okay, right. So this is the physics problem, right? Now, what they have drawn here is like a picture like that. It's not a circuit. They have not drawn any circuit. Now, how to change this drawing into a circuit like this? Can you see I'm moving around, this circuit here? Yes. Now you start with the battery. You start with the battery. The battery like that, right? So let's say this is the battery. This is the battery. So I go along this wire here, and I come to a branch like that. Two branches. You come here, two branches. So it's a Y shape there. Now this Y shape here tells me that it is going to be a parallel circuit at this point. So you start from here, you start to split up into a parallel circuit. So you see this is the battery, you move, then you split into a parallel circuit like this. Okay, so as you go along the two path here, right, the parallel circuit, the two path here, they join back at this point. So there's another Y junction here. So you see this is another junction here, the Y junction or the T junction, whatever you call it. Here is a Y junction, here is a T junction. Okay, so it is like you from the battery, you branch off to a parallel circuit, then you come back to a single one, then you go back to the battery. So this is how you're going to draw. Look for the Y junction like this, right? Look for the Y junction like this. The first Y junction you split up. The second Y junction you join back. Okay or not, Liu Ying? Do you know how to convert the drawing into a circuit? Can or cannot? Yes. So can, so I'm going to draw two branches and they are going to connect back like this. One more time, two branches, 1 2, and you join back like this. So along the path, taken, you place all the resistors, bulbs and meters there accordingly. You place them accordingly. So split into two branches. The top branch I have 4 ohms and an ammeter. So the top branch I have 4 ohms and the ammeter. When the bottom branch I only have a 3 ohm bulb. So the bottom I have only a 3 ohm bulb. And when these two join back, they pass through a 2 ohm bulb. So when they join back, they pass through a bulb. And then a switch. So a switch is here. Then go back to the battery. Okay now? So this is how we're going to do it. Okay, so actually the conventional current move this way. From here they move on like that. But the negative current, the electron flow will go the other way. So whether you look at it as a conventional current or you're going to look at it as the flow of electron, it's up to you. But for this type, it's better to you better look at it as a conventional current. When you are dealing with electronics, chapter 4, is it chapter 4, where you have the P PN, NPN, or those things, PN junction, right? Then you try to look at it in both ways, both as a conventional current and the flow of electron. Okay, right. Now, so first of all, I try to find the combined resistance of these two parallel resistors. So these two parallel one, I circle them and treat them as one, right? The effective resistance, one effective resistance. Right? How to treat them as an effective resistance? You use this formula 1 over R, 1 over 3 plus 1 over 4. Right? So finally, you have the 1 over R is 7 over 12, or the resistance, the combined resistance, the effective resistance of these two is 12 over 7 ohms. Okay, so we have found out this one. But this resistance is made series with this one. So I call the whole thing 2. So I'm going to combine this parallel one with this in series. So the second one is this, the 3 altogether. What is the effective resistance of all the 3? So since this and this one, they are series, so I just add them up. So it's 12 over 7 plus 7. So it's 26 over 7 ohms. So the effective resistance of the whole circuit is 26 over 7. Is my calculation correct? Wan Li, my calculation correct or not? Okay, correct. My calculation is correct. So knowing the total resistance or the effective resistance of this, I use V equals to IR. I use V equal to IR because I want to know how much current is flowing in this whole circuit. So the V is 3, the effective resistance or the total resistance is 26 over 7. So from there I can find the current. I call this current I2. Now you look at the diagram here. Now I2 is actually, the I2 is flowing in the 2 ohm lah. That's why I label 2, because I label it according to the resistance here, right? So flowing in this part is 2, I2. So I've calculated the I2 to be 21 over 26. This 21 over 26 ampere, when they move to the parallel circuit, they are splitted up into these two branches here. So how much of the I2 will be flowing here, and how much of the I2 will be flowing here? In order to know, since this is flowing across the 4 ohms, I call it I4. Since this is flowing across the 3 ohm, I call it I3. So actually I4 plus I3 together will give you this I2. So far you know how the current is flowing or not, right? So if you don't understand, you ask down, right? How calculate the resistance, calculate the total current. Then the total current is this part, the I2 part, is flowing in this part, before they split up into I4 and I3. Any questions then? Any question? No question? No question, show me your thumb. Wan Li and Nurul Iman. Wan Li, okay. Nurul, okay. Okay, now if you look at this I2, I2 is split up into I4 and I3. Now, how much goes to I4, how much goes to I3? Now, they will go according to the ratio of the resistance. And you look at this part here is 4 ohm, this part here is 3 ohms. So the current will split up according to the 4 ohms and 3 ohms, right? They will split up accordingly, right? So the 4 ohms having a greater resistance, less current will flow. Then these 3 ohms having a smaller resistance, more current will flow through. So this 4 is to 3. The ratio in which they split up is 4 is to 3. But it's not a direct ratio. It's not a direct, it's a reciprocal. It's the inverse of it. Okay, I will explain to you how. Now this, they will split up according to 4 part and 3 part respectively. Total, they are altogether 7 parts. So these 7 parts, this one, this current here, 21 over 26. This 21 over 26 ampere here, this 21 over 26 ampere here, this 21 over 26 ampere here, you have to divide them into 7 parts. You have to divide them into 7 parts. You have to divide them into 7 parts. Yes, divide into 7 parts. So can I say out of these 7 parts, 4 parts will flow through the 4 ohm? Can I say out of these 7 parts here, 3 parts will flow through the 3 ohms? No. Why? Because 4 ohms has a bigger resistance, has a higher resistance. So less current should flow through the 4 ohms. 3 ohms has less resistance, so more current should flow through the 3 ohms. Okay, so if I divide them into 7 parts, the 4 ohms will receive only 3 parts of the current. The 3 ohms will receive 4 parts of the current. Because it has lesser resistance, it will receive a bigger part. Okay, now, so now you want which current? You want A. The emitter is placed here. That means you want the current that's flowing through the 4 ohms, that is I4. So I call it I4. So this I4 is only 3 parts of the 7 part of 21 over 26. Okay, so it is 9 over 26, and if you use your calculator, 0.346. If you round off to do 2 decimal places, the 350.35 ampere. Answer is A. Answer is A. So any problem, Yu Ying? Can understand or not? Oh, can. Very good. Can. So you know, next time you don't have to actually calculate, making it very complicated. You see two branches there, you add up the total resistance and you know how many parts your main current has to split up. So if that part has a higher resistance, you will take the lower current. This part has a lower resistance, you will take a higher current. So that's how we use this ratio here to find out the current that is split, how it is splitted between these two paths. Any question? Wan Li and Nurul Iman? I think it's about time already. Time only 1 minute left. Okay, so if you have no question, then we're going to stop here. Right, we're going to stop here. End already, if you have no question. So we're going to end this session. Thank you very much.